Very good morning, everyone. I'm Dr. R. Niranjana Devi, Assistant Professor of Physics. Today, we are going to see about the laws of thermodynamics, which is coming under the field of thermal physics. Yes, this is the outline of the study, and first we have to see about thermal physics. Thermal physics is a study of the relations between heat, work, temperature, and energy. And especially the laws of thermodynamics are very important. The laws of thermodynamics describe how the energy in a system changes and whether the system can perform useful work on its surroundings. It is actually exact mathematical science that describes the relationship of heat and mechanical energy. Okay, there are four kinds of laws. They are zeroth law of thermodynamics, first law, second law, and third law. Especially, we are going to concentrate today the zeroth law of thermodynamics. Okay, so let me give you the statement first. If two systems are in thermal equilibrium separately with the third system, then they must be in thermal equilibrium with each other. And this is the exact definition for the zeroth law of thermodynamics. I can explain now. Consider three bodies like A, B and C. Yes, suppose the two bodies A and B are separately in thermal equilibrium with the third body C, then the A and B themselves are also in thermal equilibrium with each other. Yes. So, A and B are in thermal equilibrium separately with the third one, right? So, this A and B themselves are also in thermal equilibrium with each other. So, this is the exact explanation of this zeroth law of thermodynamics. Okay, then there are so many significances for the zeroth law. Actually, this law leads to the concept of temperature. Yes, we know all bodies in thermal equilibrium must have a common property which has the same value for all of them. This common property is called the temperature. Thus, the temperature is the physical property that tells whether a body is in thermal equilibrium or not with another body. Yes. I can give you n number of examples for the zeroth law of thermodynamics. Okay. I shall give you some examples only now. Let me explain you one by one. First one, the hot coffee becomes cold one after some time. Yes, the hot coffee is surrounded by the cold air of the room. This hot coffee loses its heat to the surrounding air of the room. This hot coffee will keep on losing the heat until its temperature becomes equal to the temperature of the surrounding air of the room. Thus, the zeroth law of thermodynamics appears here in this example of a hot coffee cup. And the next example is thermostat in a room. We know thermostat is a device which is used to detect the temperature and also maintain the temperature in a room. Yes. Here, a thermostat in a room shows 68 degree Fahrenheit, which means that the air of the room and the thermostat in thermal equilibrium with each other. So, all the objects of the room like clock, cupboard, chair, table, fan, etc. are also at 68 degree Fahrenheit according to the zeroth law of thermodynamics. They are all in thermal equilibrium, right? So, this is the second example, and the third example is vegetables in the refrigerator. Yes, we can keep vegetables, fruits and many items, milk, so many items in the refrigerator. The things which we keep inside the refrigerator will cool down and it will achieve the lower temperature as that of the air inside the refrigerator. Thus, anything kept in the refrigerator is an example of zeroth law of thermodynamics. Okay. The next example is thermometer. Yes, we are using the thermometer for measuring our body temperature. No? Yes. So our body is in thermal equilibrium with the thermometer. Yes. So a thermometer which is in contact with our body is an example for the zeroth law of thermodynamics. Okay. Then next example is temperature measurement in an air conditioners. The air conditioner has a temperature sensor which monitors the temperature of the room. It will send the signal to the electrical system to produce a cooling effect in the room. So this cooling continues until the temperature of the room and the temperature set by the user becomes equal. So the simple application of zeroth lies behind this temperature regulation inside the air conditioning system. And the final example is the last example is the temperature measurement for the industrial applications. Yes, in many industries, the hot or cold fluids are supplied for specific applications. The industrial thermometers measures the temperature of the fluid passing through the pipe. The sensor attached to the thermometer achieves thermal equilibrium with the hot or cold fluids, and it shows the readings on the dial. Thus, this industrial thermometer is an example in which the zeroth law of thermodynamics is applied. Yes. So far, we have seen about the thermal physics, and also we have seen about some laws of thermodynamics. Especially, we have concentrated today the zeroth law of thermodynamics, its statements, significance, explanation, and also some of the important applications of zeroth law thermodynamics. Yes. Okay. In the next module, we can see about the first law, second law, and third law. Okay. And thank you for listening. Thank you for your patience listening. Thank you.